Good morning, GeeCON. Looks like it's 10 past 10, so we can start. I'm glad you all made it here, despite being so early on Thursday morning. Is it Thursday? Yeah, Thursday. Um, my name is Grzegorz Piwowarek, Greg for short. I do have a bit of a solo practice at forcomprehension.com, and I do blog there a bit. I'm a principal engineer at MIME and a trainer at Bottega IT Mainz. If you have any questions to the presentation, not this part, you can go to Slido, and at the end of the presentation, I'll try to answer that. The reason I came to you today is to bring a bit of a counterweight to what's happening in our industry. Especially in the Java community, we are bombarded with new frameworks, libraries, practices. They all come with all sorts of bold statements and promises about how much things they will do for you with just by applying one annotation, one extra dependency. But after so many years working in the software industry and falling for those bold statements, I came here to tell you a couple of stories and some ideas how to circumvent certain issues. A couple of years ago, when I read a blog post about the history of Micronaut 1.0 and how they made it happen, I saw one comment that resonated with me a lot. Someone wrote there that regarding opinionated, unopinionated frameworks, at the beginning of their career, they loved them. They loved the promise of creating a whole application literally with one annotation. But over the years, as that person gained more experience, they started experiencing that it's not so colorful and joyful as it can be sometimes. And that resonated with me because I feel like it's my story as well. I remember times when Spring appeared as a competition for Java Enterprise Edition. And that was something really fresh, lightweight, and joyful to work with. But over the years, once we started adopting more ideas, more annotations, more opinionated frameworks, it started getting dangerous. And I've encountered some horror stories on production due to very simple bugs, very simple omissions, or just due to bugs in frameworks that couldn't be easily fixed. So at the beginning, I loved them, then I hated them, but now I learned how to work with them in a way that allows me to benefit from all the good things they provide while minimizing the downsides and potential bad things they can bring. And this is what this talk is about. At the beginning, let's clarify a couple of things. So frameworks and libraries, especially in Polish language, those words are almost synonymous, but it's not the same thing. So a framework is like a skeleton. It's something that creates your application, manages life cycle of your classes, objects, and does stuff for you. When you work with framework, it feels like the framework is most of your application, and you are just filling in the missing, filling in the blanks. With libraries, it's the other way around. It's like you own the application, you own everything, but you plug in those libraries whenever you want to get something done. So if you think about that in a very simple way, another Apache Commons or a simple persistence library, it's a library. But the tool like Spring is considered a framework because, well, it gives you everything. You are just filling in those classes, beans, wiring them up, but everything is happening for you. What's important to understand that frameworks exist beyond software. For example, franchises. If you want to create your own McDonald's, that's a framework for business. You go to someone to go to McDonald's, you adhere to the rules, and they give you a framework for building a restaurant. And you can go for that and probably be successful and make a lot of money. Another example is project management methodologies. For example, Scrum. It's a framework that tells you pretty much how to get better at shipping software by adhering to the skeleton that they give you. However, if you attended the keynote, you probably understand and know that it's not as colorful as promised, especially when it's treated by the book. But the good parts of frameworks is that they give you instant value, but it's not fully for free. Imagine you want to start your own restaurant, your own McDonald's, but you have this great idea that you will, let's say, flip M around. So it's no longer M's McDonald's, but something else. But the framework author, they don't let you do that. No, you can't do this. If you want to have your own restaurant, you go for McDonald's. You don't flip letters, you don't change colors, you don't change menu. It's like that's how you do it. And that can be problematic if it turns out that the problem we are trying to solve was not predicted in exactly the same way by the framework author. So as long as we go to those well-traversed paths, we'll be all good and happy. But sometimes, if we need to step out of them, it might get a bit more trickier. So usually when we think about frameworks, we think about all the good things they bring to the table. But rarely we think about the downsides of using them. So one, maybe the most obvious one, is that they take time to learn, but they outdate quickly. So nowadays, we are overloaded with information and things we need to learn. There are concepts of, engineers, full-stack engineers that are supposed now to write front-ends, back-ends, understand Kubernetes, networking, DevOps, DevSecOps, everything. But that takes a lot of time. So if you want to be really proficient at a particular framework, you need to spend time learning it and its opinions. But that knowledge that you get, it doesn't really translate well to other areas of software development. But if you learn basics of distributed systems, this knowledge will probably stick with you for a while, and you'll be able to apply it to everything around. So I am basically a no-life. I spend my life in a basement, but I still don't get enough time to learn everything I'd like to learn. So at some point, you need to make tough choices. What do you want to learn? Do you really want to spend extra 20, 100 hours on learning one new tool that will make you save a couple of lines of code versus maybe spending this time on learning something that your whole career will benefit from? But the thing is, those tools go out of fashion. They get abandoned. So Java Enterprise Edition was a big thing. Then the Spring appeared. But Spring did grow a lot over the years. And many tools now are trying to fight Spring the way Spring fought Java Enterprise Edition. So now we are getting Micronaut, Quarkus, the rise of micro frameworks. I'm not saying they are bad or something, but there is a possibility that a few years from now we will be writing our software using totally different stacks than now, because things change. And then we'll need to go for the whole process all over again, while the basics of distributed systems that we've learned, of internals of databases, they will stick with us. Another thing that's often overlooked is that they increase complexity and weight of projects. For a long time, it wasn't really a problem, because if you had a couple of machines sitting in a company's basement acting as your servers, you wouldn't really worry about that, and that your hello world actually takes 1 gig of RAM. But now, with all the movement to the cloud, suddenly it started mattering. Because, the promise of the cloud was that you can fire all your infrastructure people and everything will be done for you in the cloud. But hey, but then the AWS bills come. And then you realize that actually Hello World's waiting 1 gig is not a viable solution anymore, because it turns out it's more expensive than keeping all those infrastructure people that were sitting in the basement and maintaining those servers. And to be fully candid, actually all those frameworks, including Spring, got much better at it over the last couple of years. Another thing is, sometimes they require expert help. So it's all open source, right? But usually all the bugs, all the bug fixes, critical security fixes are ported to most recent version. But maybe keeping with most recent version is not one of your priorities. So you probably adopted one of the tools. You really didn't feel like migrating every couple of weeks to a new version. And then it turned out that, well, suddenly it's not a couple of weeks, it's a couple of years. And then some critical bugs, security bugs are found in that software. And now you have a couple of options. Either usually spend a lot of money and ask for expert help for the vendor to provide a fix for you, because that's usually what you need to pay for some historical version of a library or the framework, or you do it yourself. And that's usually how the very painful journey starts, where you decide to fork a very old library and develop it on your own. And from my experience, usually it ends up that this fork doesn't feature just a very critical bug fix, but starts growing on its own. So this can be not cool. So it's also quite interesting how the approaches vary between various communities. In my early days, I spent a lot of time in the Scala community, and they are totally afraid of frameworks. So when you go to some Java communities, if you go to pages of frameworks, you will see bold statements saying pretty much, we'll do everything for you. But if you go to the Scala ecosystem, you will see them rather saying, oh, I'm not a framework, I'm just a toolkit. Just take whatever you want, and I promise I won't mess with your code. So this is quite interesting to see how it differs between various local bubbles. Something messed up. But all those problems actually originate in one observation that Joel Spolsky made a long time ago. Over 20 years ago, he wrote a blog post about, which can be summarized with one sentence, that all non-trivial abstractions to some degree are leaky. So imagine you have a simple abstraction over subtraction of 2 integers. That's not very demanding, that's not rocket science. There are not many moving parts that can break in there. But suddenly, if you create an abstraction that's supposed to abstract out all the implementation details of dealing with relational databases, that's a bold move to make. And quite likely, some internals will leak out and make it problematic to you when you really don't want it to. So for all the frameworks and all the tools to do all this nice magic, they usually resort to a couple of black magic techniques. Those are things like runtime reflection, class path scanning, thread locals, runtime annotation processing, dynamic proxies, aspects, and so on. And don't get me wrong, those are great techniques, very useful, but if you put them all together, if you combine them together, that can usually result in pretty bad to hard to debug bugs. So if you speak to Jarek Ratajski, that keynoted yesterday, he'll tell you a story where in his company they went live to production, and for example, the transactional annotation stopped working. I personally spent over 2 weeks working on one contract where after migration from Hibernate to another version of Hibernate, For some reason, one of the tools responsible for incrementing a sequence was causing a deadlock on a database. At some point in time, we had a situation where all our metrics disappeared, and we figured out when the service went down. And even once, we went to production not with a real database, but with H2 working in memory. Well, because something figured out that if I'm missing a bin, it would auto-configure something for me. So it auto-configured H2, and we went live. And our infrastructure people went very crazy, saying, there is no load on the database. And we are like, how come? But the system's working. Yeah, not fun. So to give you a bit more insights in what does it mean that abstractions are leaky, let's take as an example this piece of code. A classic, you have a transactional annotation over a method. And I have a question for you. It's really hard to have a conversation in a room like this, so please just raise your hand if you think if you know where the problem is, if you're confident that you know where the problem is. Okay, a couple of you, good to know. Okay, but probably some of you didn't raise your hands. So let's try to calibrate the room. Please raise your hand if you are in the room. Okay, now data is a bit more meaningful. Okay, so the problem here is that transactional was placed on top of a private method, and annotations like this don't work. In order for the transactional to kick in, it works internally by creating a proxy, but you can't really do that with private methods. Let's go to another one, a bit more complex. So now we've fixed that. We have a public method called create credentials with transaction on top of that. But now we have method create user, which creates credentials and does a couple of other things. Do you know where the problem is here? Okay, a couple of you again. So the problem is that if you call a method create user, it calls method create credentials, but that method is not proxied. The proxy is created, it's probably injected somewhere in other places of the code. So if other code calls a proxy, the transactional kicks in. But if a create user method that's not transactional calls a create credentials method, it doesn't use a proxy. It calls it internally, which means that transactional does not kick in at all, which can be a bit scary at times. And now suddenly you need to figure out how to hack it around. So now we know that the internals leaked out. We know that there is a proxies involved, so in order to make this work, we need to somehow call the method through the proxy. So we need to figure out. Then we try to hack around. We inject application context. We try to resolve reference to the same object directly from the Spring context. And now we can call the method by calling self-reference. But this self-reference is a proxy, and now it works. So as you can see, this can get weird and complex at times. And this is, for example, why, if you go to the Scala community, that's how they see Java development. Because they see Maven, Spring, Hibernate, they see all those issues, and they get scared. So how would a Scala engineer write that code? Well, I'm probably getting canceled for that in the Scala community, but let's try it anyway. So imagine that transactional is gone. What can we do? We can use a tool like transaction template, which essentially accepts a lambda expression, and everything inside that lambda will be executed in a transaction. And if you start thinking about how many fewer things can go wrong here, it's a huge number. With transactional, you are writing just one single line of code, but there's quite a lot of code involved that you don't see. But if you do that with a transaction template, it's just a single lambda expression. There is no proxies, there is no magic. You don't need to think if any magic happens to make it work, because it's simple code, it's simple lambda expression that gets called and executed. You can think about it as a execute around or template method kind of implementation. And this is This is very easy, and the same patterns can be applied to any many other annotations, and it makes things way simpler. Gives you peace of mind that no stuff can break there. Yes, we did write a couple of more lines of code, but I think that my experience over the years showed that those a few more lines of codes are probably worth it. And by the way, yeah, I'm not praising Scala developers here. They made mistakes as well. So let's say we've adopted Spring, or let's say a tool that actually uses a lot of magic. What's specific for Spring is that they use a lot of auto configurations based on what's present on the class path or not. But what we tend to do often is go a bit crazy over the top with dependencies, especially if you're in the in a microservices project. Usually what I've seen happen quite often is that someone figures out that, hey, we tend to repeat those dependencies a lot in many services. Let's create a shared module and put them there. And someone is trying to be very helpful to all the colleagues in the project. So they will put there Spring, all modules of Spring, Java Enterprise, all versions of Hibernate, 3 different persistence frameworks, 5 different serialization issues, drivers for 5 databases, and so on and so on. And then that module gets shared and gets pulled in as dependency for many different projects. And now sometimes weird things start to happen. Maybe not when things get stable, but imagine that you pull quite a lot of transitive dependencies, but you figure out that you need a new version of this particular one. So you bump one up, but this bumps a couple of others up. And that can, for example, mess up auto configuration or other things, and they stop working the way you expected it to. And those things are terrible hard to debug and not very fun too, as well. So what's the best thing we can do? Let's go 0 dependencies, right? No dependencies, no problems. But this is actually a pretty good thing if you are building shared modules libraries. If you can avoid dependencies, this makes it very convenient for everyone that actually uses your library or module. However, as you guess, this is probably not that easy to do in practice because we don't want to re-implement everything, literally just to avoid a couple of dependencies. But if we are, let's say, building a shared library that internally uses, let's say, a Jackson, and you don't want to expose that, all of that can be shaded, repackaged, so that from outside you can't see it. Things would get way more easier if JPMS was adopted, but it's everyone kind of ignores that. So we don't really have any better tool to do that. Another thing is how to make sure that we maintain that idea over time. Because it's very easy. Someone actually created the baseline of the project, and then left the company, and then it starts living its own life. It's easy to forget about those many details and choices that were made along the way. And it turned out that, for example, ArcUnit is a great tool that can help you maintain and stick to those rules that you've established at the beginning of a project. But that's not about ArcUnit. So another very common and leaky abstraction, ORMs, Hibernate, JPA. It works really good, especially during conference talks, which are very short and focused on happy paths. So if you have a simple user model that has just an ID, name, and a couple of other strings, no complex relationships, that will probably be very easy and be successful with that. But what often happens is that if you start developing your software over the years, it accumulates all those weird decisions that you needed to make, they tend to accumulate. And it starts to look more like that. And it's not, let's say, if those are just Hibernate JPA annotations, that's fine. But what I've seen happening is that you would mix Jackson serialization, XML, JSON, persistence annotations, Spring annotations, Lombok, and others. And that's that's not fun to debug, because sometimes you might see annotations that sound like they should work together, but they don't really because of reasons, and that's terrible to debug and live with. The big problem with, let's say, Hibernate and JPA is that it kind of encourages you to mix together domain code and persistence code. It usually becomes one entity. And usually it's a good idea to keep those separate. So if you, at some point in time, if you figure out that you want to go away from Hibernate to something else, it's really hard, because suddenly all your domain actually relies on how JPA handles things. It relies on lazy loading, transactions, dirty checking. And let's be honest, this is really hard to undo if you want to change. If you want to change, let's say, persistence providers in this case. If you want to learn more about JPA, and if you want to be convinced that you don't know how JPA works, there's a great presentation from Kuba on this topic. So, but what was the problem with SQL? SQL was great. It was complete, self-sufficient, but it just wasn't type-safe. But there are libraries that solve that particular issue. There is a great one, which is paid for most commercial products, Juke, which allows you to pretty much write your SQL queries using Fluent builders. Super useful. Then there is JDBI, which is my personal favorite, which allows you, where you still write your SQL code, but it provides very convenient and comfortable API, and allows you to avoid doing the annoying dynamic string, concatenation if you want to get some more complex queries, right? If you're in the world of Spring, you can go for JDBC template, which works just great. So, well, it's just a database client. You execute a SQL statement, you get a result set back, and the whole magic is included in that mapper, in the example below. You just write a simple mapper where you take a result set, you extract values from it, you put it in an object, and you forget about your persistence. There's no lazy loading, dirty checking, just simple code that takes essentially a hash map or a map with strings and converts them into an object. And you stop worrying if your dirty checking kicked in or lazy loading didn't cause n+1 issues. That's all you need to worry about, how to convert a map into an object. And that's the whole problem. And that simplicity is beautiful. There's also one more interesting project, Spring Data JDBC, which is kind of like a concept of like Spring Data JPA, where you keep all those classic JPA annotations, but without all the lazy loading, caching, dirty checking in place. I would suggest you to have a look at that, but after playing with it for a while, I noticed it doesn't really behave the same as JPA would in certain cases, so I would normally go default to JDBI or JDBC template. If you're in Kotlin world, you can try Exposed, which is another very cool way and very convenient, non-invasive way of accessing your data source. But the point of this presentation is that frameworks and tools, they will only be invasive if you let them do that. So in the original example, we had JPA, which became part of the domain. Domain persistence is all merged together. But there's a very simple way we can avoid that. So even if we are working with JPA, we can create separate model just for persistence. So the whole domain is encapsulated in the domain layer, but persistence is managed by different classes. And yes, it might look, we'll be writing a bit more code. That code might look duplicated. But if you look at this code, you just start thinking, what are the reasons for those classes to change? You'll see they are totally different. So, so even though this code looks the same, those are two user classes with both IDs and names, you will see that over time they will have different reasons to evolve. So perhaps the domain model will stay the same, but we'll change the way we persist user. And then usually those models start to drift away. And then you start seeing the benefits of that. If you don't do that, usually you end up with one big class that has a lot of workarounds that allow you, for example, to skip certain fields in JSON serialization or treat some fields differently for the sake of persistence, persisting them. But if you separate them, this gets super easy. So you take this persisted user from a repository, and then you convert it to a domain. And suddenly, your worries about lazy loading, all the magic is gone, because you're operating with simple domain models, which ideally should be free of frameworks and unnecessary libraries like that. What's more, I've said some bad words about Spring today, but let me tell you that actually I'm rolling out a new Spring service at my work as we speak. It's not like I'm not using it. I'm using it, but I'm trying to keep some ideas in mind. And there are some very simple tricks you can employ while using Spring to make it slightly less invasive and less problematic in some cases, so you can still benefit from all the good parts. So let's take this very simple example. There is this foo facade, which injects a foo service. It has a method annotated as post construct, which calls another method. And now if you start thinking, how do I instantiate that class? It's not really obvious, because the constructor there's default constructor. We didn't really create any public API for that class to be instantiated. So if I wanted to create it, I would need to look at the code and figure out, okay, what dependency does it have? Oh yeah, it has full service dependencies. Then instantiate it all manually, then inject it manually, and then, oh, there's a post construct method. I need to call that as well. And only then I'll be ready to work. That's a lot of things to worry about. So the first things we can do is to create a public API for creating that particular class. So we forget about injection via fields, but we go through constructor. And that's also what the Spring team recommends as well. So in this way, we have public method for creating a class. And Spring is, instead of using magic to set fields, it's relying on the constructor that we've created. And in the newer versions of Spring, since many years, you don't even need to use the auto-wired annotation. So Spring suddenly is not someone that does weird things with reflection to your class internally, but now it uses the same API that you would use to create that class. But then you figure out, hey, I don't really, maybe that post construct was placed here eagerly. Maybe we don't need that. Maybe let's just put that in constructor. So if we need to initialize, we need to call that method when we create a class. Maybe let's just call it in a constructor. And suddenly, it's a bit easier. If someone wants to create that, they know they need to provide a new implementation of full service as a dependency to the constructor, and that's how you get your object. But hey, where's the config? The config is now in a different class, annotated with add configuration annotation. And now those config entries, they all call the same code that you would call if you wanted to create an instance of this class. So look, and that's a few simple tricks where we arrived with the domain code that's free of Spring annotations. The Spring obviously is using your code, but it's being slightly less invasive when it comes to how it sets and what it does with those internals of an object. Spring now just calls the same code that you would call if you wanted to wire all the application by yourself. And this is the same. That's the same example. We wrote slightly more code, but suddenly we are slightly less dependent on Spring's magic to wire everything together for us. If we don't have Spring, if we don't have magic annotations, that has also a couple of other cool benefits. So imagine you have user session repository and you want to introduce caching. but you have very convenient caching annotations for that. But if you start thinking now, how do I test that? If I just create a class, I can't really test the caching, because for this to work, I need to wire the whole context of Spring or some other tool, and only then the magic starts working. So I already know that those tests probably won't be very fast, because I'll need to keep wiring all those contexts to make it work. But is it really so hard to implement your own caching? Not the cache, just the logic responsible for putting things into cache or evicting it. So maybe instead of putting annotations there, maybe you can create, for example, another implementation of that interface that decorates the original code with caching. That's very simple. It's a couple of lines of code. And the benefit of that is that you can test it without any Spring context. And you have this peace of mind that if you create this class, if you create an instance of that object, you don't need to worry that those annotations will not kick in, because it's plain, simple, dead boring code that evicts, let's say, the content of a cache or puts things into a cache after we're interacting with user session repository. And all those small and tiny things, they actually matter in the long run if you are playing a long game. So if your context is that you have a deadline in 3 months, you know that you are working on an outsourcing project, you know that you need to ship something in 3 months, but someone else will maintain it for next couple of years. Usually, let's be honest, you are not motivated to play the long game. But what you will see when you start working with product companies is that suddenly you start thinking, okay, that software we are writing is going to help us sustain the business for a decade. And suddenly, all those small things, all those small cuts, all the technical debt, all those shortcuts, they compound together and can bite us back. And that's usually when the project manager comes to you and asks you, when can we move that button 2 pixels right? And you start telling them that you need to make architectural changes into 15 microservices and orchestrate the deployment so it can be done by the end of, in 6 months. And what I noticed, what plays out really well, is thinking about coupling and cohesion. So usually we're very good at modularity and encapsulation at the high and low level. And by low level, I mean the university-style encapsulation. So you all know, private fields, public getters, that's encapsulation. Over the last couple of years in the industry, we learned about microservices, which is modularity at a very, very high level. But what we often neglect a lot is the modularity in this middle layer. So if you start thinking about how we work with our code, how we organize code, especially in the legacy projects, you'll see that there's quite a lot of random interactions. So think, for example, that red dots represent some classes responsible for renting a movie. So those might be services, repositories, and so on. Yellow ones are, for example, user management. And all the classes from the host, all the layers responsible for that. And the green ones are, for example, account management or inventory management, and so on. In this case, let's say we have a couple of contexts, and you can see, for example, that those red dots probably figured out that it's very convenient to reach out to a repository of account management because it's easier. It was easier to take stuff directly from a database, and so on. And that's how spaghetti code is formed, where you don't have any control over layers and how the interactions happen between various contexts in your code. And what we would like to achieve is to end up in a situation like this, where you identify, isolate contexts, for example, movie rental, account management, inventory, create public APIs for them, narrow the API surface, and make them talk for those public APIs. And if those modules interact only through the public APIs, you have freedom of changing implementation details And as long as you don't touch the public API, in theory, nothing should change. So in here, we've separated those in 3 separate components. And now, if we want to, let's say, totally rewrite the account management, as long as we don't change the public API, the rest doesn't change at all. And that's super really convenient and allows you to push this threshold, push the border of when your code starts degrading. Because that approach is not a golden mean. Your software will start degrading at some point. But the idea is to push that border to the point where, so that you experience it as late as possible. So another very cool idea that's worth recalling and learning is hexagonal or clean architecture or onion. There were a couple of names. People keep reinventing it all the time. It's very easy, I promise you. So it's very easy. That's usually how you do it. So you have domain layers, you have application layer, driven adapters, secondary adapters, primary driven adapters, search engines, search adapters, search persistence, application core, and so on. And here are the managers, and so on. So as you can see, very easy. And usually, this can take a couple of days to teach you how to work with that. But the cool part about this is it's actually very easy. It can be explained in 1 sentence. And if you want to adopt it, you don't need to make huge commitments. You can adopt it piece by piece, pretty much for free. And the idea of hexagonal architecture or ports and adapters, clean architecture or so on, is to use interfaces. Keep your domain code separated from integrations. And because your domain code doesn't need to know about your database, or if something is provided by a separate service, it needs to know there is some store of data. User service knows that there is some repository of users, but this can be Postgres, this can be JPA, something accessed through JPA. That can be something in Hazelcast. That can be separate service. That can be a file on a disk. The domain doesn't need to know. And again, there's a count repository. This can be whatever, but the domain doesn't care about that. Domain cares how to get an account from somewhere. It doesn't need to know where from. And then you create separate, and then you create actual implementations of those that actually plug into your domain and provide that functionality. Suddenly, things become very much easier to test. Suddenly, you don't need to mock so many things. Suddenly, you don't need to use H2 as a workaround, as a compensation mechanism for your tests, because they are very slow. Because, for example, you can have in-memory implementations of those repositories faking the original one, and those will work slightly better than mocks. Because I'm sure you've seen situations where there was a lot of mocked code. Everything was so mocked. Everything was green, but the code didn't work at all. That's why people joke that Mockito is one of the best tested libraries in the world. The same, you go from the other side. So if you keep all the domain logic outside of controllers, and treat web controllers, HTTP controllers, as just a way of exposing domain methods to the outside world, suddenly you don't need to worry about testing everything through HTTP layer. Everything is encapsulated in the domain. HTTP layer exposes it to the outside world. And if it's happening this way, then all your tests will be going through the domain, which is probably IO-free, which means those tests are super fast. And then you write proper integration tests and check if actually your HTTP layer works as intended. It's much easier to maintain a real testing pyramid in such case. And to use the last couple of minutes, I'd like to show you a real-life example with Axon and Kafka that we encountered a couple of years ago. And again, that's not something you should do, because it made sense for that particular context a couple of years ago. It would not probably make sense now, because there are tools like Spring, CloudStream, and so on. The problem was, a couple of years ago, I worked for a company where we had 150 microservices utilizing Axon framework heavily, which is a framework that helps you with event sourcing CQRS, and they claim to help you with evolutionary microservices, which means you start with a monolith, modular monolith, and then you put those classes in separate services, and things start working transparently. And that's true. It was an old version of Axon, Axon 2, I think. And Axon, by default, it relies on Axon RabbitMQ module, which assumes that you want all your communication to be happening via RabbitMQ. But we reached a point where RabbitMQ wasn't good for us, and we were looking for something more scalable. And we identified that Kafka might make sense. So you might be thinking, okay, so what's the problem? We just swap Axon RabbitMQ with Axon Kafka. There was just one big problem with that. The Axon Kafka didn't exist. So we ended up in a situation where we need to figure out, okay, so we either migrate away from that. No, we can't really migrate 150 services at a time safely. Maybe we develop a Axon Kafka module by ourselves. And that's actually what happened. One of our engineers was working on that for a couple of months. Or perhaps we could try something else. And that's pretty much how we solved the problem in one evening after fighting a couple of months with a new Axon Kafka module. By the way, Axon has a Axon Kafka module now. So what we did is that we didn't try to, hack the framework. We didn't try to write our own modules. We tried to push the framework outside of our code a bit, so that it's not in control, but we are in control. And the way it worked is that Axon had event handlers that would delegate that if an event arrived, it would automatically dynamically route it to a particular method. But that's simple code. That's just a map of a couple of routes where you can point, okay, event with this key needs to be paired with this method. That's not a big deal to write it yourself. It's not a big deal to create your own map like that. Yeah, it looks kind of ugly, but it made sense at that point in time. And the routing logic is super easy, because you just check if that key is in a map, and if yes, you route that message right there. And suddenly it becomes very easy, because if the framework is not owning your code here, but you are owning it, you can plug in whatever you want. So in one evening, we managed to plug in the Kafka event stream configuration. So all the code for that particular service would work with Kafka or with RabbitMQ. And those are two different Spring profiles we could plug in whenever we wanted. And that's an example of benefits you can get when you push those things outside of your domain. Again, this is very specific, very contextual, and it made sense. That's not something you should default to when you start a new project. So after a couple of months of work, we managed to solve it in one evening just by not trying to cooperate with a framework, but by isolating it. And one last thing I'd like to try to show you that you could try is the tool that I like a lot, and I enjoy it for small microservices that don't really require that much magic. It's Ratpack. It's a bit fresh again, it's a collection of Java libraries, and it's very fresh in comparison to what you are probably used to when working with Spring. So the way you configure it, yes, you need to write a bit of code, do things by yourself, but at the end of the day, you get this peace of mind that everything is just wired by you, that if something goes wrong, you can easily debug it, and it's pretty lightweight. So maybe if you're writing your own next project, maybe you could try this one from scratch. But as a last sense, I'd like to remind you that the best practice is to use common sense. So for a couple of years, I've worked mostly for product companies that had their products, they invested heavily, they had long runways, but that's maybe not your context. So I don't know your context. If you want me to get to know your context, you need to invite me, and then I will send you an invoice. But now I don't know your context. So remember, those are tools. I hope you understand pros and cons, but it's up to you to identify if they make sense in your context. So thank you very much, and I hope you learned something. I don't think we have time for questions, but you can always catch me here. I'll be around for the next couple of days. Thank you. Do we have time for questions? Okay, so the first question is, why did you leave Scala? Oh, that's a tough one. Are you recording? So there were two things that contributed to that. When I started Scala, I started it a long time ago. I think the first time I was exposed to Scala was at my university times, when one of the professors was actually enchanted by it and pushed it. And I liked it a lot. At that point in time, there was a huge difference, because those were Java 6 or Java 7 times, I think. And the difference between what Scala offered versus what was in Java was enormous. The difference was huge, so it was easy to fall in love with the language. But over the years, Java started catching up. So the difference between this and that is the Java and Scala is not that big anymore. Along the time, the Kotlin appeared, and Kotlin appears to be actually doing slightly better at being better Java than Scala trying to be a better Java. What's more, I've seen a couple of Scala projects which were totally broken, and they were broken mostly because total overuse of various crazy programming techniques, which Spring developers never dreamt of. So if you see a project in Scala, let's say with overuse of shapeless implicits, that gets way crazier than what you can get with Spring annotations. What's more, the community started being pretty toxic, so I decided to move away from that. In your JDBA example, how do you gracefully query for nested objects? If you have a nested structure, you still probably you wouldn't probably serialize your own object and rely on passing the whole object, but look for particular properties of a nested object and use it in a query. So the same way, it's JDBI template. It allows you to write simple queries. You can template them. You can inject some values in there, and that's usually enough. Never had any problems with that. So if you stop thinking about objects and start thinking about queries and the shapes of those queries and properties that you want to query, suddenly it's not the problem anymore. Why would you create an interface when you have only one implementation? That's a great thing. So the reason is that I usually would have more than one implementation, and I would use those implementations in tests mostly. What's more, I would quite often have more than one implementation and use it just for dev. So imagine a simple scenario. Imagine you have a big project. It relies on, it has some queues, Kafka, free databases, and requires 4 services to make it work. And there is this poor front-end person that comes to you and they say, I want to move that button to 2 pixels left. And you tell them, OK, so you download Oracle, download Kafka, set up this, and in 2 weeks, maybe you can run your project locally so that you can iterate on the front end. What I would do quite often is to create a separate implementation working purely in memory, literally on a hash map. Or, for example, some services that are not critical, I'll just create some dummy implementations and create separate profile in Spring for that, only for developers. And usually those profiles I would use just for development, experimentation, or just helping someone, like front-end people, to get backend working so that they could iterate on things. Those work just in memory, so which means data is not persisted, but it's really convenient. It's really convenient because you can start your application like this, and it works right away. It's also pretty cool if you start from scratch. So you are building a new service. You probably don't, when you're building a new component, especially if you are at the phase when you're working for separate in another team, where you need to figure out, but you don't know how APIs will look like, what it will integrate with. It's probably easier to start with interface, create a dummy implementation, and not integrate with the database or other services right away. But you start with interfaces, dummy implementations, which later evolves into something else. So usually, for me, it's not a big problem. And I wouldn't create interfaces for everything, just for those, in those places where I want, integrations with external systems or tools. So that's where I would, pretty much by default, put an interface, because I want to keep those separate. How many layers of user objects we should have in app? Okay, that's a good question, and I think I know what you're asking about. So usually, if you start separating layers, you will figure out, you will arrive in a situation where you have a lot of code representing the same concepts. You might have a user that's a persistence model, then user in domain, then another user which goes outside of boundaries of partial module in the form of public API, and there is quite a lot of mapping. So usually I would have separate model for persistence if I really need it, if it's more complex. But if you're working with JDBI or so, usually you can get away without a persistence model, because you can convert what you get from database directly to a domain model. With JPA, it's necessary. You need to have separate classes because they are the carriers of your data. But with JDBI, result set is a carrier of your data, and then you convert it into a domain object. But then you end up with a separate layer of objects for going outside of module boundaries. And if you are working in projects, simple services, usually that's okay to be pragmatic and not separate those. So if you have at the beginning domain models being exposed through HTTP controllers, that's kind of a trade-off which is more or less okay, which will be okay as long as those models don't drift away. But if they do, then it's not a big deal to actually change it so that you have introduced another layer, but then it's really needed. So you don't feel the pain of mindless mapping between DTOs, because that's where it's actually needed. Okay, we don't have time. Okay, thank you. Slides will be posted on my Twitter, and yeah.